Good evening, everyone, and a warm welcome to Insider Crypto News family. I hope we're doing something good for our Indian community and Tamil community. Thanks for your big love and support. I have no words to describe your love and support. I feel extremely honored to introduce our guest, Mr. Wolfie and Mr. Wolf. Yes, welcome to our family. We are very great. We are very Yeah, we are very grateful accepting our invite and marking his presence here. We are really thankful to him for taking the time out of his busy schedule to attend the AME. Welcome, Mr. Wolf and Wolf.
Hey, thanks a lot, guys. It's very flattering to be invited to speak on the behalf of the Kaspa currency project and, to explain to people who are interested in cutting edge technology in the crypto arena. So it's great to be here and to be invited. And thank you very much for the opportunity.
Yeah, thank you, Mr. Wolfie. We are very eager to learn about Kaspa in this AMA. So, shall we start the AMA with technical questions?
Yeah, that's great. And just to proceed my answers and my participation overall. So I'm I'm part of the Kaspa. There's no team, but there's a group of contributors that work on it every day. I'm one of those people that's a contributor that works on Kaspa every day for over a year now, but I'm not working on it in a technical aspect. I'm not a programmer. I haven't studied computer science. I'm not a math guy, and I'm not a cryptographer. So what I do is business development, and of course, helping to manage the community and tweeting a lot about it. And for the business development category, what that means to me basically is trying to propagate the technology out and have Kaspa live on as many other existing platforms that are out there for cryptocurrency, namely mining pools, mining software, and exchanges, both centralized and decentralized exchanges. So that's what I do. So when I'm answering technical questions, although I have several decades of experience running technical businesses, I'm not a computer science guy, and I'm not a developer, and a coder. So I don't understand it like the guys who wrote the actual software. But maybe not a lot of people in the AMA. Maybe a lot of people in the audience aren't in that category either. So maybe it's a good match. I have a general understanding of how everything works, so that should be good for this session. Okay.
Yeah, Mr. Wolfie. First of all, thanks for being frank and being open. But we are just learning the basic things for Kaspa to invest and like that. So only just basics only we are going to learn about from your side. So before going to technical questions, I want to ask some friendly questions. Do you ever visit India?
No. So I don't know how much anybody believes in the zodiac signs. I don't particularly believe in it scientifically, but there's some traits of that seem to match up that I've experienced. So I'm a Cancer. I'm the crab, and they say the crab likes to stay in the shell at home. So I don't travel too much, especially internationally. In my life so far, but who knows? As the crypto space develops and as Kaspa takes a larger grasp on, it becomes more widely known, perhaps in the future I'll be traveling around the world. Yeah, I have not been to India yet, but maybe I'll be able to come and catch up as Kaspa takes a firmer grasp on the cryptocurrency market overall. Maybe I'll be doing a little tour in a couple of years.
Yeah, Mr. Wolfie, we are ready to welcome. So shall we ask some basics questions now?
Yeah, let's go through the questions you guys compiled. That should be fun.
Yeah, how POW work in DAGs?
So the proof of work in a DAG is not from the way I've experienced it, and from what I can tell, it doesn't work any differently than any other proof of work project overall. In general, the miners are guessing a string of characters that start with zeros, and once they get one that they think is a good answer, they submit it to the network and hope that block gets accepted. Now, the part where it's a little interesting with the blockDAG. So let's talk about DAGs overall. So the DAG, that stands for directed acyclic graph. That's not a new term that was made up for cryptocurrency. From what I understand, it's part of math and computing for at least since maybe the 80s or the 90s. So that just means it's a shape of a way of arranging data in a shape with no particular structure other than you have these points, and it can get big and it can get small. So Kaspa is a unique project in that there are other DAG projects, like Constellation is a DAG, but from what I understand, that project that arranges transactions themselves into the DAG structure. Kaspa is unique in that it arranges the blocks into the DAG structure. So that's a new thing. I'm going to drag and drop a little teeny GIF into if you guys can see that. I think I'm in the right channel. The Kaspa AMA channel. See the blocks going by? In case some of the community of yours never saw this in action, this is what our structure looks like. As the miners create those blocks, there can be one at a time, there can be two, there can be 5, up to 18 at the same time. So it's a little, it's a lot more advanced than having a blockchain. The blockchain only has one dimension. It has length. So like Bitcoin, for example, that just has one block, and then 10 minutes you have a straight line where nothing happens, and then on that same straight line 10 minutes later, on average, you're going to have another block. So we have a two-dimensional structure that somehow actually requires three-dimensional math to create. And with this two-dimensional structure, we don't only have the length, we have the width. So that enables a lot more surface area for transactions and confirmations to take place much more rapidly. The goal, like the primary directive or the goal of the creation of this technology was our founder, Jonathan Sampolinsky, who's a fantastic wizard and highly regarded in the crypto community overall as a pioneer. He's very anxious in getting things results. So he said he always compared to like Google, like a Google result. Like, can you imagine if you typed something to search in Google and it takes 10 minutes to get the answer? That's ridiculous, right? Can you imagine if you go to Netflix and you start trying to watch a movie and it doesn't start for 30 seconds? That would be annoying, right? Like, you expect to, like, you push the button on the internet and then something happens. And why should crypto be any different? Why do we have to wait 10 minutes? Why do we have to wait 15 seconds for Ethereum? Why do we have to wait anything? It's the internet. We shouldn't have to wait, So that was the founding principle, of Kaspa, and it's already come to fruition. Within 10 seconds, we're already confirmed, and it's going to get a lot faster on the Rust programming language rewrite. So that's kind of a roundabout answer, and I know I got off topic a little, but I hope that made some sense and got some good information across.
Thank you, Mr. Wolfie. I think this is a best explanation and very clear and very brief. Yes. So our next question is: instant finality and scalability is there. Then how about security in Kaspa?
From what I understand, the actual definition and the meaning of finality is something that if you're really a pure crypto proof of work project that follows like the Bitcoin playbook, so to speak, which Kaspa has 100%, then you want to avoid finality. So from my simple understanding, finality is like kind of like a stamp, like somebody saying like, this transaction, this block is done forever, no matter what. And Bitcoin itself doesn't have that, and neither does Kaspa. So finality, from what I understand, is more like like the validator, like proof of stake or validator networks like Binance, like BNB or Solana, where you just have like 20 or 30 servers around the world that are in control of saying if blocks are okay or not. After some mechanism, they all agree that a block is done forever, then they put that stamp of approval on it and it's locked in forever. Which kind of, to a regular person, and even to me, I admit, sounds, oh, that's kind of good. Okay, they say it's done, it can't be undone. But for like for the real mathematically pure and for the real way things should be, that's not what you want, really. Like, our founder and a lot of other computer science and crypto experts and founders and programmers could explain why it's bad. I don't exactly know why, but I know they think it's terrible. And it's like a vulnerability, or there's something bad about it. What it is, I don't know, but we don't have finality. We have here's a math word I learned last year. It's asymptotic, and asymptotic. That means like approaching an amount or a value, but never exactly reaching it. So Bitcoin is asymptotic in getting like almost immeasurably close to being final, but never exactly final. And Kaspa is the same way. So it's just, we have blocks and blocks piling on top of each other, and then everybody agrees that they're legit. And the more blocks you stack on top of it and bury the old ones, the more near impossible it would be to go back and change that. So that's how Bitcoin is since 2009. And that's how Kaspa is since November of 2021. So we're all of the nodes are in consensus and agreeing that something's a valid block, and then when you put another block on top of it, it's more seriously cemented in for good. And then when you put, we put on millions and millions of blocks. So things that happened a year ago on Kaspa are really well cemented into history. So I hope that makes some kind of understanding. Now you say the scalability is there. That's correct. And then the last question was the security. So our founders and the developers who came up with this technology for Kaspa, they stuck to, when I say they stuck to the Bitcoin playbook, like the way that Bitcoin did things and launched, and the principles of Satoshi, they really did, note for note. So the GhostDAG that we're running on right now, that protocol, that's a generalization of Nakamoto Consensus. And what that means is they basically figured out a more robust, or a way of, the blockDAG way of having simultaneous blocks and arranging the blocks on a DAG, but it still follows the rules perfectly for how Bitcoin validates blocks. So therefore, from sticking to the plan of Bitcoin so well, we're able to derive the exact same amount of security at a matching hash rate as Bitcoin. So it's perfectly secure, as just as secure for a proof of work coin as Bitcoin is, if we were to have the same amount of computing power as Bitcoin. So that's a pretty good amount for me, or that's a pretty high level of security. I don't see how it could be any much better for a coin that's in the wild, that's being mined by people around the world. It's fantastic.
Thank you, Mr. Wolfie. And in future, like Ethereum, Kaspa will in like Ethereum, Kaspa will migrate proof of work to proof of stake for saving energy and global warming.
Nobody can really predict the future. I would have to say I would doubt that Kaspa would actually change to a proof of stake coin, especially I think Jonathan, our founder, has mentioned that the DAG Knight protocol, which we're going to be speaking about a little later, that's going to be worked on this year. That one, I think, in one of his speeches within the last few months, he said that the concept of it is only valid for a proof of work, cryptocurrency. So if we implement it, then that would kind of rule out the possibility of moving to proof of stake, it would seem. However, DAG Knight itself, the idea of not having any assumed latency. That was thought of to be an impossibility. Like in people who live in the land of theory, you know, people, mathematicians and programmers and computer science guys that live in theory world, and everything is in the imagine if, what if we did this and this formula and that formula and this group of circumstances, you know, those guys, people like that, thought it was impossible to do what DAG Knight achieves, and then it turns out it's not. It took 3 years for them to figure out how it wasn't impossible, but they did, and they proved it on paper with math and formulas. So that's pretty cool. So we can't say it's never going to be proof of stake. Like I would be reluctant to say it might not be exactly proof of stake, but there may be some way with the fantastic minds that are at work here in the next maybe 5 or 10 or 15 years that the amount of energy required could be reduced, at least, I would say. You know, so things are possible when there's a good motivation and you have fantastic minds like this. I wouldn't say it's impossible for some other, at least, energy saving technology to come into play at some point in time. But for right now and for the foreseeable future, it's going to be a mined coin.
Thank you, Mr. Wolfie. Can you explain about modified version of heavy hash algorithm?
Sure. And this is where the expertise of Wolf 9466 comes in, but I can start it off here. And if he wants to chime in a little bit. So heavy hash overall is just an algorithm. I don't know why they call it heavy hash. He does. But in my experience, you know, I'm a miner. I started mining Bitcoin in 2011, and I have a bunch of video cards, and you know, I've mined different stuff on and off. And you know, right now I've been mining Kaspa for over a year, and it's called heavy hash, but it doesn't make a lot of heat, and so it doesn't seem like it's doing anything too heavy to me. That's why I'm not a a coder guy. So there's a regular algorithm that's out on different coins, other coins before Kaspa, called heavy hash. Now the K part of heavy hash just refers to the Kaspa version of heavy hash. So they take the heavy hash little puzzle or sequence of calculating the hash, and they add one more little trick, one little extra math trick in there before it's done. That's the part that Wolf 9466 could tell us exactly what that trick is if he wants. Wolf, are you around? You want to tell us what the extra trick is that makes it K heavy hash and not just regular hash?
It just fills the state or the working data of the hash with a bunch of values before it does the hash itself. So on both the input and output.
Interesting. See, I knew he would know the answer. Thank you, 9466. We appreciate it. So yeah, so it's a neat little algorithm, and they honed in on this algorithm, I think 24 hours before the chain went live in November of 2021. Well, it's not a chain. It is a chain, but it's a blockDAG. A chain is a blockDAG with a K of 0. That's what I always have to remind myself. So when the width of the blockDAG is just one block, then you have a blockchain. But when you expand it to allow multiple blocks at the same time, that's what makes it be a blockDAG. That is what we're looking at with Kaspa. Anyway, yeah.
I was going to say DAG stands for directed acyclic graph, which is a really fancy term for it's a tree.
Very nice. Yeah, that's pretty neat. Yeah, we can see that in the little GIF, and I'm going to post a link to the live block visualizer also, so you guys can watch it in real time. So it's pretty neat to watch. Sometimes it looks like just one block at a time, and I put the link. Oh wait, link's not allowed in the group. I'll see if I can put it in the other group. 1 second. Okay, it's not. Anyway, it doesn't matter. Yeah, so K heavy hash is neat. It doesn't use a lot of electricity. It's very efficient. People are using like 50 watts or 100 watts. for per video card, and they're getting a decent amount of computing power out of it. I've had, I was running Ethereum for years, and I've had my office. I have about 30 video cards in my office where I come to every day, and I'm speaking from right now. And when I was running Ethereum, it would heat up my office pretty heavy, and I have 2 air conditioners, and they would be running pretty full blast for Ethereum. And now with running all Kaspa instead, my AC, they cycle on like every 10 or 15 minutes, the air conditioner comes on, but it's not generating a tremendous amount of heat, and the electricity watts that I'm using is a lot less. And one other thing I just have to point out about mining Kaspa is, and when you had mentioned moving to proof of stake, it's not such a wasteful thing to be mining Kaspa. So due to the fact that we have miners around the world participating and submitting simultaneous blocks, and there's no orphans in Kaspa. So
yeah, everybody is mining, but they all have a chance to get a block that's proportional to their hash rate. The only waste is when every time there's a new block on the network with Bitcoin, the waste is everybody has to stop what they're working on and switch. With Kaspa, that's not exactly the case. They can switch when they're done.
Very nice. See, having a true actual wizard in the chat helped a lot. So we all learned something extra today. Thank you, Wolf9466. So that's our answer. That's our combined answer about the K-heavyhash.
Thank you, Mr. Wolfie, and thank you, Mr. Wolfie 9466. Yes, Mr. Wolfie, we send that link. So if you send that hidden link, I will send it that group. Please check. So the next question: why a proof of work project don't have a major entity investment?
Sure, that's a great question. So I have to start off by saying, in fact, Kaspa has had a major investment, but it was an investment in the research and development to bring this glorious structure that you saw on the screen to life. So there's a very large crypto venture capital company. They're called Polychain. And a long time ago, in 2017, I believe, they seem to have been intrigued by our founder Jonathan Sampolinsky's ideas for creating this multi-block structure. So they had some chats together, and somehow they came up with they agreed to form a research and development company, and they funded it. So they put $8 million into that company, which was called DAG Lab. So most of the guys, there's no core, there's no team, but the guys who work on the actual Kaspa software every day, most of them, if not all of them, they were hired employees at DAG Labs in that time from 2017 to 2021. They all were working there and trying to make this thing make sense on paper and then bring it to life, and it was not an easy task. It took about 4 years, and it took some money, and they needed paychecks to eat and live from. So there is investment in the technology, but to keep it fair, they did a fair launch, and it wasn't like the type of thing where you have an ICO and there's some corporation and they make all of these tokens out of thin air in 20 seconds with a smart contract, and then they keep 45% for the VC company or something of the tokens. That's not how it happened with Kaspa. Kaspa just did a fair launch, just like Bitcoin. They announced it. They picked the algorithm, that K-heavyhash, like 24 hours before they started off the blockDAG, and then everyone started mining, including DAG Labs. They spent a little bit of their last money on some cloud computing time, and they mined some coins for themselves too, which is still fair and square. And so there's money in the concept of Kaspa, which is a POW project. Now, there, once these things are launched, once real crypto, which is like the jungle, I always like to say, it's like anything you can get or take is yours to keep. Like with Bitcoin, if you come up with some some amazing machine, you know, an ASIC computer that's 20 times faster than everybody else in the world, and you can mine Bitcoin faster and better and get most of the Bitcoin, it's yours to keep. It's the jungle. Whatever you can catch, you can keep. So, you know, and Kaspa is no different. So I would think, though, you know, some you know, investment corporations might be reluctant to participate in something like that, put money in where they don't have control over the outcome. You know, a lot of times large institutions like to have control over stuff, which is kind of understandable. If you have a lot of skin in the game, you want to kind of have a hand on the steering wheel as well. It's not real. I wouldn't really fault them for that concept. But anyway, and you know, like people like Michael Saylor, he's a company, and you know, he has his company, and they buy a lot of Bitcoin. So down the line, I don't think it's outlandish to say that perhaps some larger entities, once they discover how magic and you know, revolutionary the Kaspa technology is, that they might, you know, add some to their portfolio. It's perceivable. It's not a crazy idea at all to me.
Thank you, Mr. Wolfie. And the final question: explain something about GhostDAG and DAG Night.
Sure. So it's not going to be anything like the people who invented it would be able to explain it. But in general, GhostDAG is that concept that the DAG Labs company worked on and brought to life. And that's just the ability of having multiple simultaneous blocks, and not just having one block that points to having, when you create a block, it doesn't only point to the one block that preceded it. It points to all of the blocks that it's aware of at the time of making that block, something like that. So that's why when you look at that visual representation of the blocks being generated, the lines that point, you know, that connect to blocks that come later, those are literal. They're not just, you know, they're not just like cool artistic renditions of what it might be going on. It's telling you, like, you know, this block knows about this one and this one and this one, and this one knows about only this one, and this one knows about this one and that one. You know, so it's pretty neat. And you know, right now the GhostDAG, we have our block time set at 1 block per second. So on an average, we keep it so we average 1 block per second. Now, one of the questions were a topic that we didn't include in the questions, which is fine because I'm going to slide it in right now, is the Rust programming language rewrite, which is great. Rust is a high performance computing language. Right now, our network is running on our software is built on Golang. That's a different language that comes from Google. So when they came up with the idea of GhostDAG, and in the lab at DAG Labs for several years, they programmed the different modules in Golang, and it was I think of it like more like a modeling clay. So they got the shape and they got the ideas, but it's not something that you would put in a museum, you know, that's you know, easy on the eyes and, you know, aesthetically pleasing. That's just an analogy. So now that they have the shape and the outline, and we have 100% uptime for over a year, and the network's super stable, now it's almost done now. It should be coming out at least on a testnet next month in February. They rewrote it in Rust. So Rust is a programming language that has a lot more control over the hardware from how I understand it. So it's able to access the multiple cores of a CPU. So these days, even cell phones, even smartphones have 8 cores or more, or, you know, 4 cores, 6 cores, 8 cores, whatever. And, you know, a regular computer is going to have 8 cores or 16 cores these days. So Rust programming language lets you program and talk to different cores. And also, I think it has better access to the hardware memory. So in Rust, what's revolutionary that they're coming out with is the ability to validate different blocks simultaneously in different cores in the computer. So that's pretty wild. So I think of that kind of like if you're checking out at the store Like, you're at the supermarket, you have your cart, and there's only one line. There's only one person on the cash register, and you have to wait your turn. So, and then finally, like some more workers come and they open up 3 lanes or 5 lanes or 8 lanes. And then the one long line you were in, then everybody splits out and everybody goes to a cash register, and everyone gets handled like that. That's what's happening with Rust. So all of a sudden, we're going to have inside the core of one computer has the capability of saying, like, this block's good and that block's good and that block's good and that block's good, all like instantaneously. So when we see these multiple blocks coming up at the same time, the core of modern computers is going to be able to check those blocks out and give them the stamp that they're valid and add them onto the blockDAG. So that's really cool. And the testing speed of the throughput of this is amazing. Like our I forget the specifics, but they did a test, and how our right now software could process this test pile of blocks. It took 23 minutes. And the new software on Rust, it took like 45 seconds or something, 38 seconds, like less than a minute, so it's about 30 times faster. So that's incredible. So that's super cool. So that's GhostDAG. Now, excuse me, on to DAG Night. DAG Night is amazing, and it took 3 years, the idea. Like I had said previously, it was originally thought to be impossible. Like, there's, I guess, a thing in theoretical computer science and math called an impossibility. Like, even though regular people walking around every day say anything's possible, in the land of math, anything's not possible. There's things that are considered impossible, and the idea of having no assumed latency in distributed computing, like crypto projects, was thought to be an impossibility. But they proved it. It took 3 years. It was created by, even though we have no lead developer, if we did have a lead developer, his name would be Michael Sutton. So Michael Sutton came up with DAG Night, and it was coached by Jonathan Sampolinsky. And it took those guys 3 years of really paying attention and thinking way outside the box. And they proved on paper how it's actually possible. Now, what this is highly complicated, but I have a general understanding. I'll explain to you guys how I understand it, and hopefully it gets, this is a Michael Sutton approved analogy for regular-ish type people. So here we go. If you remember, when the virus was really bad, the COVID thing, and there, everyone was going crazy and things shut down, and traveling was very inconvenient, because if you flew to someplace else, like another country, you had to quarantine when you get there. So I'm in America, so if I go to Canada and I get off the plane, I have to go to a hotel room for a week, whether I'm sick or not, it doesn't matter. I just have to go in a hotel and stay by myself for a week. Then I get to pop out. So I have to wait 1 week, no matter what. Doesn't matter if I'm sick. Doesn't matter if I'm not sick. I just go and I hang out for a week. Then I get to come out and walk around in Canada. So right now, in all proof of work coins, excuse me, got a little scratchy throat there. All proof of work coins, we have this assumed delay. So this programmed in. They program it. Bitcoin has it. Kaspa right now has it. They have a fixed amount of time that we have to assume there could be a problem on the network. We don't know. So just in case, we're going to wait, 10 minutes on Bitcoin, say. In case it takes, when Bitcoin makes this one block, the next block, it's going to wait no matter what, 10 minutes, not the block time, but this is a different number in the software. It's going to, just in case, like, there's a node on the other side of the world that, has bad internet, we're going to wait this 10 minutes or whatever it is. And Kaspa is the same way. I think Kaspa waits like 18 seconds right now, just in case, the network's slowing down, or there's some internet problem, or someone's attacking, whatever reason that it may be difficult for a node somewhere else far away on the planet to get this block and realize that it's one of the new blocks, we're going to have this timeout where we don't do anything. So DAG night is revolutionary in that it doesn't assume there's any problem. So it doesn't make you go to the hotel for a week before you can come out and play. So it assumes zero latency, and it assumes no problems on the network. And it has a sensing mechanism to detect if there are any problems. So it's running at not, it's cruising along and it's zero wait time. Then if the sensors mechanism detects that there's some problem, like, hey, wait a second, it seems like it might be starting to take a bit longer than usual. We're going to start scaling in a little bit of delay. So it sets the dial from 0 to 1 or 2, what that is, it's some amount of time, milliseconds maybe. It starts waiting a little, and then it keeps monitoring, and it looks for if it's getting worse or is it starting to go away, the problem. And if it gets worse, then it adds in a little more. And if it goes away, then it goes back to 0. And what this will achieve is like when we're speaking about, pushing the button on the internet, and you expect it to happen like by the second on the up click of the mouse, you expect, the result. And it's going to have the confirmation time of Kaspa be reduced even further. So you push the button and you initiate a transaction on Kaspa, it's going to be an instantaneous result, and that's groundbreaking. There are people that are very, very smart, and that have mentioned that this is potentially the most revolutionary or the biggest breakthrough in distributed computing since Bitcoin itself came out in 2009. So that's coming from somebody that's been paying attention for at least 20 years in school to computer science, not me. So that's a pretty good statement. I like it.
Thank you, Mr. Wolfie, for very patient, and I thank you to Mr. Wolf 9466 and Mr. Wolfie for very patient and give your explanation very neat and clear. We learn more in this AMA about Kaspa, and we will upload this AMA in our YouTube channel too. We wish, as a part of Crypto Insider News family, we wish Kaspa will be a big successful and big upcoming big successful huge project in crypto industry very soon. We wish as a family, Mr. Wolfie.
Hey, thanks a lot, Maddie, and thanks for inviting us. And it was our pleasure to come and share some knowledge. Hopefully it made sense, and you guys have a little more insight and can recognize it as a really interesting and forward compatible with crypto type of technology.
Thank you, Mr. Wolfie, and thanks to whoever joined and very patient and eager to learn about Kaspa. So thanks to all of our teammates and friends. So we will close our AME now.
Okay, guys, take care. We'll catch up to you soon. Thanks a lot and have a great day.